Okay, so this talk is going to be unlocking new opportunities with Tezos X. I'm going to focus a little less on the technology stack behind Tezos X. I think there's been a great blog post explaining that, and I've talked to this at length in previous talks, and more about what it enables and a bit of a review of the use cases that exist for blockchains. I'm often in a position of giving a negative account of what is possible on this technology, because I think we are in an industry with tons of hype, or I mean, there's nothing wrong with hype, but I would say misplaced hype. You hear that blockchain is going to solve X, blockchain is going to solve Y, and it's always without an article, it's blockchain. And the reality is that it's a very exciting technology, and it's a very exciting technology for certain use cases, and it can go very deep in those. But it's also not a cure for cancer. And it's important to have a level-headed idea as to what use cases make sense, which ones are going to stick around, which one really have strong potential. So what is Tezos X? Just a quick review. So the first, it's a proposed design, obviously, because anyone can build a roll-up on Tezos today. Then Tezos X can be built. That's just a thing. But there's also aspects of Tezos X which depend on the layer one. So in this proposed design, a lot of it has already come to fruition with the smart roll-up engine in Mumbai, with the recent launch of the data availability layer, who's going to keep evolving. And the characteristic of that, one is modulitic. That's a neologism we found. It's modular but monolithic. It's modular in the sense of that you have a separation of concerns, you have a separation of execution, of data availability, of consensus. But it's modular in terms of architecture while providing an integrated experience for users. And I think that's very important. I had a debate 2 days ago with Mustafa Al-Bassam from Celestia, and for them, the modular aspect is not just about architecture. They're saying, no, you're going, as a developer, you have to build your entire chain yourself, and you're going to grab a sequencer from these people, and you're going to grab, your data availability from these people. Yeah, I don't know if you've ever seen the TV show Seinfeld. It's a place where you make your own pizza. You get the dough and you roll it, and as a developer, you want to focus on your application. You don't want to focus on grabbing all of these different pieces. You want an integrated experience that just works. And that's been part of the narratives that Solana is trying to push. With a monolithic approach that's very, very friendly. Saying well, look, it's friendly to developers. You come just here and you build, and it's just all there. And so we're trying to get the best of both things. We're trying to scale while remaining decentralized, and that implies a modular approach. But we're also trying to provide the experience of a monolithic blockchain, which is what I would say is the most friendly for developers. Performance is very important. Tezos started out not as a high-performance blockchain. It was very, very focused on the store of value use case, which I think is one of the most important ones for cryptocurrency, and being a form of digital gold. And for that, you don't really need a ton of transactions per second. But markets have evolved, and dApps have become very important. DeFi has become very important. People want to have lots of transactions, a lot of complicated smart contracts, and that's been reflected in the evolution of Tezos over the years. So lots of performance. Composability, that's a part of staying modular, meaning any contract should be able to call any other contract. Again, in contrast to the vision of rollups who somehow have difficulty talking to each other, or don't even talk to each other, or go through custodial bridges. Here we have contracts that can atomically talk to each other and compose. Interoperability, that means being able to use any programming language that you want. Most of the world today runs on JavaScript and Python and C and .NET and Java. It does not run on Solidity or let alone Michelson. And providing interoperability for these languages is super important. Again, in a use case where you are defining small contracts focused on store of value dynamics, that's one thing. If you want to build large full-thread application, it becomes important to be able to tap into the tool chains that exist for a lot of mainstream programming languages. And fundamentally, I think the goal with Tezos X is to reach something like almost a cloud-like backend, right? You can think of blockchains as being very expensive in general. And that was true for a while. And it's still true on blockchains like Ethereum, for example, where you're going to pay $30 for a transaction. And when you think like that, you have to always think about your use cases for blockchains in the light of, well, what is going to justify this cost? If it's so expensive to use a blockchain, you really need to be tapping into the core value prop of the technology to justify using it. But if it's so performant, if the transactions are so cheap, then in some sense you start not caring as much. In some sense, it becomes almost a drop-in replacement for cloud computing, but one that has payments, identity, all of this feature tagged in. But I'll go back on that. So this is a proposed roadmap for Tezos X. You've seen this graph probably. So there's a lot going on here. At the bottom, you have the block time. We started at 60 seconds. We're now at 10 seconds. The goal is to get down to around 5 seconds. I don't think it's worth pursuing sub-second latency on the L1 directly because you start hurting your decentralization, and you want to keep the L1 very decentralized. But 5 seconds, I think, is a good sweet spot. I don't think, once you start going below a minute, you're already deciding that people are not going to run validators through Tor. Like that's a political decision. You say, you know what, you're going to have to run your validator directly on TCP. But once you've crossed that bridge, I think with 5 seconds, you could be, you could be reasonably using a Raspberry Pi and Starlink in the middle of the Sahara if you want to. So I don't think you're cutting out many people. Under 5 seconds, it starts becoming a little dicier. Maybe you can go below, maybe you can go to 3, but you're not going to go to 400 milliseconds. Without like severe compromises in terms of like where those computers are going to be. Like if you want 400 milliseconds, everyone's going to be in a data center. That's the reality. Data availability. So that's new. And if you are a baker, I encourage you to run the DAL node because I think the goal is eventually to make it really a part of what every baker runs. That's super important. That is the second leg of scaling. One leg of scaling is outsourcing execution to roll-up nodes, and the other part is to share the download of transactions across all the bakers, and to allow, of course, people running full nodes to verify that the data is available. So we're starting out with just 1 megabit per second. Sorry, that's megabyte per second. So if you compress transactions, you can get your transactions down to about 12 bytes per transaction. That's with aggregating signatures and amortizing a lot of things. You can get to about 12. So 1 megabyte per second will give you about 1 megabyte divided by 12 will get you about what am I saying here? 80,000 transactions per second. So that's already quite a bit you can cram in there, and then progressively going higher. But I'm wondering. I think it should say 1 megabit per second. I'll have to check that. And then ultimately going to something like 100 megabit per second. So 100 megabit per second give you roughly 1 million transactions per second with a 12 byte transaction. And in the layer 2 side, so we're starting out with Smart Rollup and the EtherLink Rollup, which is in beta now on mainnet, but we'll have an official launch coming soon. And then there's quite a bit of development that's coming here. One is adding MEV protection. MEV is a big topic in DeFi. Essentially, it means that people who decide the order of transaction right now, they can inject transaction that take advantage of the transaction that they receive. They can reorder transaction. And we're tackling this. Currently, the approach that we're taking to tackle this is to encrypt transactions. So every transaction is encrypted with threshold encryption, and then after its order has been decided, then it gets decrypted. That's still being implemented. It's very much a goal of the EtherLink project, but it's not live yet. However, it's a very robust way of avoiding MEV. Then the integration of EtherLink and the DAO, so that EtherLink can have more data availability and not take all the Tezos block space. In the meantime, we're also working quite a bit on a Mikkelsen rollup. So that's an execution environment that's very similar to what you have on a Tezos L1. And the goal for that is to be somewhat fused with EtherLink. So think about it as having a rollup on top of Tezos, which has the latency that, sub-second latency that is currently enjoyed by EtherLink, but is able to run all the Mikkelsen application which already exist on L1. So any protocol that has been deployed on L1 should be able to deploy in that rollup. But the beauty of it is that it would have instant communication with EtherLink. So it would run on the same rollup node, which means you can transfer assets instantly between the two, which is very convenient, and possibly even have some smart contract composability. So that's the beginning of having multiple languages and multiple execution environments in one rollup. And it's very important, of course, because Michelson remains, and I think the languages we have on Tezos remains an excellent way of building safe applications. We invested quite a bit of R&D in making it a great language, and we absolutely want to make it a big part of Tezos X. And that's why I think once we have EtherLink going, the next step is to add Michelson. The RISC-V engine is a big project. So we have been using WASM for the rollups, and WASM works great, and you can build pretty much everything you want with WASM. However, in developing EtherLink, we noticed a few difficulties. One was that for performance, we require rollups today to get a good sense of how much execution step they consume. They have to do their own gas monitoring. And that unlocks a ton of performance if you do it, but it's also extremely complex. And one of the main difficulties in EtherLink was actually getting the stick count correct. And it's going to be always a barrier for the development of rollups and potentially a security risk. So we're rethinking that with the RISC-V engine. RISC-V is a simpler instruction set. It's easier to compile to RISC-V from more languages than it is to WASM. RISC-V also allows us to do certain things like just-in-time compilation of JavaScript, which we couldn't really do in a WASM environment. And we are including tick counting in it. And what that means is that the rollup engine will take care of your gas. You do not have to implement gas. Now, I know that it sounds like I'm going into the weeds here, but when we were developing Tezos, the first version of Tezos that launched, the part that was the hardest and the part that took the most time and the part that created the most technical delays for the launch was the gas model of Michelson. Like by far, everything was working. The last piece was the gas model of Michelson. Gas metering is just generally a very hard problem and very hard to get right. So with the RISC-V engine, we're basically saying we're going to get it right at the level of the rollup engine, and then that's it. Now it's a big technical challenge because if you want to do this without having too much of a slowdown, you need to deploy a lot of tricks for emulating the RISC-V engine, and we're working on this, but it is a very exciting area of research. The JavaScript rollup, you've probably heard of Justice now, or JSTZ. It's a rollup environment where you write your smart contracts directly in JavaScript, and they connect and talk to other smart contracts as if they were web servers, so it's an interesting and novel idea. And we're going to do something a little bit different with Justice in order to get a lot of developer feedback, because fundamentally the goal of this is really, really good developer experience. We're going to run a version of Justice that's currently centralized, but that developers can use as a testnet to try it, get feedback, build applications, and get as much feedback as possible before we actually launch something like Justice. And finally, all of that is supposed to converge into a canonical rollup, a big rollup with lots of transactions per second that can support JavaScript, Python, Michelson, EVM, all sorts of environments, all communicating with each other. And there's going to be a lot of interesting work to be done here because it's really building from a fresh ground and rethinking what does account abstraction look like, for example, on a blockchain like this. What do calling conventions look like? How does it interact with wallets? There's a lot of work to be done. But the beautiful part about writing a rollup like this is that it's a lot easier than writing a blockchain. You don't have to worry about your peer-to-peer layer. You don't have to worry about your consensus. You don't have to worry about your data availability. You're only writing an execution environment. And I say only, it's still a big piece of work, but a lot of the scary and hairy part of a blockchain are essentially being taken care of by the L1. And yeah, in all of this, I would say there's some evolution of the L1, but not as much. The L1 starts focusing on providing very robust consensus, very robust data availability, and fast blocks. So the cornerstones have been the canonical rollup for execution, a lightweight layer 1, and that's the beauty of it, because the more you move to a layer 1, the more lightweight the more you move to a layer 2, the more lightweight your layer 1 become, because it doesn't have to do as much, the more you can speed up block times. and the more decentralized you can be, and the DAL for data availability. Okay, so one way to describe it is it could be Tezos Broadband moment. So you can see before Broadband, you have this pixelized image, and look, now it's all sharp. And in the same way that the move from dial-up to broadband transformed the web, Tezos X can mark the end of the blockchain dial-up days. The 56 kilobit per second, that's pretty much where we're stuck, and it severely limits the type of application. What happened when internet moved to broadband? You had all of a sudden video on the internet, music, a lot more interactive experiences with website. It really changed how people engage with the content. And I think that we can see the same thing happen with blockchains. As the throughput increases, as the fees go down, you can start, and also as the developer experience improves, you can start building much more advanced application. So let's go back a little bit to what a blockchain is good for. And the bread and butter is censorship resistance. That's what blockchains provide. It provides censorship resistance and permissionlessness, but it's the same thing. What is permissionlessness? Well, you don't need anyone permission because no one can censor you. So they're very much the same thing. Lack of no need for trusted third party. Why? Because a trusted third party could censor you or could extract rents. And historically, censorship resistance has justified the higher cost and lower performance of blockchain. Most of the time, and I remember having discussions like in 2012 or so, and I was talking to I talked to someone from the insurance industry, and they were saying like, I have an idea for insurance use case, but first answer this question for me: can you put data on a blockchain? And I'm like, yes. And they had some idea of like putting some documents on a blockchain, but the point is like whatever they wanted to do, you didn't actually need a blockchain. Like it was 99% of blockchain use cases, people had some ideas, and if you remove the blockchain, the idea just works as well. And the question I had for them is like, do you need censorship resistance? And if you don't, why are you using a blockchain? But the assumption behind this is fundamentally that the cost is high. There's a little graphics at the bottom. In terms of this is also a topic that's come in terms of like tokenization of assets, for example. Some assets have what I call intersubjective value. So a currency, money, for example, has intersubjective values. The reason I value money is because other people value money. So the money in my pocket is valuable because I can exchange it for goods, and I can exchange it for goods because it's also valuable to that other person. So it's circular, and the fact that money has circular value like this completely breaks people's mind. And that's why so many people relate to Bitcoin and a lot of other things. They just won't accept it. Like and even today you hear ridiculous things like it has value because people spend money with proof of work. No, that is not why. Like people really want it to be concrete, or a protocol has value because there's revenues and fees being paid, and they really don't like this intersubjective idea, but we have plenty of evidence now. And I think there was evidence before that. If you look at the story of the Swiss dinar, for example, in Kurdistan, of money being completely circular. Art is a great example. Art has value because other people ascribe value to it. It's not something that's intrinsic. And that's, again, the people who say, oh, I can just right-click and save your JPEG, don't get it. The value is intersubjective. It's not the bits in them. It's a provenance. It's all of that. Domain names, the reason the domain name is valuable is because, when you type www.tezos.com, you go to a certain address. But that's because you've chosen a certain DNS provider. If you had chosen a different one, I would go somewhere else. But we've all agreed to use the same registry for domain names, and as a result, domain names can be valuable. Now, things which are not intersubjective, livestock. Take a pig, for example. So you can tokenize a pig on a blockchain, and the problem is that you might have a token of a pig. It doesn't mean you have a pig. You have to trust someone. You have someone to deliver the pig. It doesn't matter what the smart contract says. At the end of the day, all you have is a token of a pig. Whereas, with an NFT, if you have your NFT, you have your NFT. If you have your Tez, you have your Tez. If you have your Bitcoin, you have your Bitcoin. If you have a token of a pig, you have someone's promise to give you a pig, but you still have to trust the person. Real estate, same thing. You've tokenized a lot of real estate on Tezos, and it's good. And like ledgers are useful, but we have to remember that there's a trust component here. Like it needs to be enforced, and there's some enforcement that's going to happen outside of the blockchain. And same thing goes with stocks. So these things, they do have a possibility of censorship. And so there's always a question: is like, does this make sense on a chain? And yes, but we'll get to that. So key deliveries for Tezos X. Performance, we're looking to get 1 million TPS. So if you were at test dev last year, you saw that we did a 1 million TPS demonstration. However, that was across 1,000 rollups. So here's the challenge: is to get 1 million TPS across a single rollup. Sub-second latency, I think that's very important, and it's a good sweet spot because with sub-second latency, it's hard to notice. As a human being, we have reaction times, I think, on 200 millisecond type of thing. So if you are around 400 millisecond, people are going to click. They don't even notice the time. So there's a sweet spot around there, and less than 10-second finality. I think people care less about finality, or they care sometimes they do care, but if they do care, I don't think 10 seconds or like a minute makes a big difference. But we're already at 20-second latency anyway for finality, so it's not a big jump to get to 10 seconds. Interoperability, sorry. So integration with other chains and non-blockchain systems, so specifically around languages, but also having a really good bridging ecosystem for Tezos and other chains. And composability, no fragmentation, and atomic operation across environment, which means that if you write a smart contract in JavaScript, you should be able to call a smart contract written in Solidity, which should be able to call a smart contract written in Michelson, and so on and so forth. So I want to say that as performance go up and costs go down, we can go beyond just the use cases that depend on censorship resistance. We can do more than that. Because this question of like, why would you use a blockchain doesn't cause itself, It's like, why would you use a blockchain? Well, why wouldn't you not use it if it's extremely cheap anyway? If you have this very high performance and this very low cost, it weakens the argument that somehow you need censorship resistance to justify your blockchain. And I know that I sound weird saying this, because if you go to any blockchain conference, it's like literally no one, almost no one is making the argument that, no one in the industry, I would say, is saying like, oh, well, if you don't have censorship resistance, why do you do this? It's like exclusively some OGs making this argument, some Bitcoin maximalists, and some people who don't like cryptocurrency. But it's a real argument, and I think it's too often forgotten. Like when people say, "Oh, we're going to I don't know, man. Like we're going to put every air conditioner in the world on a blockchain," that remains nonsense, And it's a good argument. Like, why do you need a blockchain? What is a blockchain going to do for you? At the same time, if it costs you nothing to put it on a blockchain, why not? It runs. It's a cloud where basically the user is paying, so you don't have to pay a bill to AWS or Google Cloud. It's just there. It's convenient. It exists. Why not? But for that, you really need to have truly, truly, truly low cost. Like that is not happening at $30 a transaction, or even at 1 cent a transaction. That is happening at lower cost than that. So the idea is like, instead of just talking purely about censorship resistance, we can talk about minimizing trust. So in the example with pigs and stocks and all of that, you do have a link of trust, but just because you have one trust link with the real world doesn't mean that you're not removing a lot of intermediaries and you're not removing a lot of trust. And so it could be that, well, sure, I'm going to have to trust a person to deliver the pig, but I don't have to trust, a dozen intermediary that otherwise would be in place when I trade. I don't have to trust the marketplace, for example, not to run with my money when I go and trade the pig. So there's a lot of intermediaries where costs that can be eliminated, eliminating need for trust, eliminating need for cost being paid. So minimizing trust, I would say, is a framework to look at. So what's the problem with intermediaries? There's always a risk of information asymmetry with intermediaries. There's a risk of fraud. The more layers of trust you have, the higher cost you have. Same thing with intermediaries. So essentially, it's lowering costs. And the case for having assets like pigs, stocks, and all of that tokenized on a chain is essentially lowering those costs and lowering those barriers. And basically keeping the minimum amount of trust, which is just the actual delivery of the product or the link between the digital representation and the product. That's one irreducible component, but just because it's there doesn't mean that you don't have the benefit of eliminating all the other layers. Reducing friction, again, so they reduce technical friction. Assets can move very easily, and it's very easy to create and deploy application. If you have ecosystems which are siloed, building applications that talk to these different ecosystems can be very difficult. A lot of intermediaries do not offer APIs, do not offer any of that. That's the benefit of composability, and that's also why you want to have everything in one environment so that things can just work together seamlessly, and code and applications can be deployed in weeks instead of years. So it's a permissionlessness and the ability of basically all of this to become programmable. Without credibility, we're not going anywhere. So why is that? Well, one of the questions I received sometimes when we were working on scaling Tezos in the early days of 2021, saying like, well, the blocks are not full yet, so why would we scale? And the answer to that is, and also today you would say, well, even across all blockchains, we don't have 1 million TPS. So why do we need 1 million TPS? And the answer is credibility. No one who has a use case that takes 1 million TPS is going to build today on blockchains because they just don't offer this type of capacity. So you don't see those use cases, in part because the capacity is not there. And so you want to demonstrate credibly that you can actually have this capacity for this use case to even rear their head. And today, when people look at blockchains, what do they see? They see Ethereum, where it's costing $30 a transaction. They see Ethereum layer 2s, which don't have a lot more throughput and which are held by multi-sigs. They see Solana, which seems quite brittle and still very much in beta stage and doesn't have nearly the throughput that it claimed. I remember back when Solana was claiming 60,000 transactions per second. They don't do that anymore, saying that now they claim a few thousand. So I think people who have been looking at this space have very reasonable concern about scaling. And that's why I think it's important to bolster the credibility that Tezos has as an ecosystem to support this type of application and to support this type of scaling without high cost and without friction. So credible scaling and decentralized scaling for Tezos X. So if you're a serious actor, you don't want the risk of a bottleneck. You don't want the risk of a blockchain whose governance is beholden to only a few people. You want millions of TPS with low fees. You want a strong governance system. You want decentralization and no fragmentation of the ecosystem, right? Because if you were trying to build on an L2 of Ethereum, what should you build on? Should you build on Polygon? Should you build on Arbitrum? Should you build on Optimism? I guess maybe they're going to get together with a superchain, but you don't actually get great composability out of this. It's all very centralized. You could try to build on Solana, but it's mostly scams and the chain stops and it's a beta quality. So you want credibility, and that's what we've been trying to build. And part of the approach of the ecosystem and the ethos of the ecosystem of not bullshitting, I think is important in building that credibility. So there are some new opportunities that are open with very high throughput, like I discussed. So some criteria. So you can look at use cases which go beyond pure censorship-resistance. So anything that involves trust minimization, anything that involves reduced friction, anything that requires significant scaling, interoperability, or that strongly benefits from composability. So finance, I think. I think finance remains one of the major use cases for blockchains because at the end of the day, they are built to move assets. That is, the problem that is solved is, double spending. And so they are networks meant to represent assets fundamentally and assets transfers. And if you don't have asset transfers in some sense, there are a lot of technologies you can use. You can simply use decentralized data storage, for example, can do a lot for you. What decentralized data storage cannot do for you is mutation. It's funny because people often say that blockchains are immutable, but a lot of what they achieve is actually mutation. You have an account, you have money, and now someone else is going to get their own account and is going to get that money, and that's a mutation. And the trick of blockchain is representing mutation using immutable data structure. That's the main trick that they pull. And so finance remains very much, I think, a central use case. One slogan I like is on-chain as a new offshore. So people don't have a good sense of offshore finance. Offshore finance is still extremely important. The naive version, I would say, that people have of offshore finance is people go offshore not to pay taxes. That doesn't work. modern countries, will not let you just not pay taxes just because you're going offshore. However, what offshore does is that they produce tax-neutral platforms for a lot of financial product. So if you are in the city of London today and you are creating CLOs, those are incorporated as listed companies in Cayman, for example. Why is that? Well, fundamentally, a CLO is like a smart contract, but you can't really build a smart contract in real life. You don't have a blockchain substrate for doing it. So as a result, people turn them into companies. The problem is if your company is taxed with corporate tax and all of that, that's not really going to work. It's not going to work as a smart contract. As a result, people go offshore. So a lot of this finance has gone offshore simply because they offer neutral jurisdiction with actually these are places which have strong financial regulation. So financially regulated, but tax-neutral platforms for international finance have become extremely important. I think there's a place to be had for blockchains here because it provides this neutrality and because it provides this predictability and programmability. So that, I think, a use case that's been insufficiently tapped upon. And the problem is no one wants to go on stage and say offshore is great because it's not sexy. It sounds somewhat bad. And as a result, I would say things went wrong in 2012 or so, when a lot of people in the Bitcoin community were afraid of the hit they were getting. All these blockchains are just good for crimes and so on and so forth. And so people went on stage and say, wait, we can also do supply chain. And it's been with us ever since. There's a few things you can do with supply chains, specifically digital twins. And so there's value. Don't get me wrong. But 90% of it oftentimes doesn't make sense. It's always on as well. No business hour. It's always present. A new secondary market. So we've seen a lot of STOs back in the days, and Tezos was a chain where a lot of STOs took place. But I would say that what motivated STOs in 2019 is you had a lot of asset issuers who looked at the blockchain world and say, wow, there's a lot of people who just made a lot of money. And these are a distribution channel for me as someone looking for investor. So I think the thinking that a lot of people had was, if I tokenize my primary offering and I go on a blockchain, I'm going to tap into all this network of investors because all these people who made a ton of money, buying Bitcoin, buying Ether, or trading a bunch of tokens, the main thing they want to do with their money is get rid of all of this weird cryptocurrency risk and put it into something real. And absolutely not. It's not this class of investor at all. First of all, they have access to REITs and they have access to other products, but also they were people who were interested in alternative assets, and they were people who were interested in high volatility. So selling them low volatility investments was not a good fit, and also I don't think the chains worked that well as a distribution channel. And so I think some people kind of wrote off the idea as a result. The other thing is that they were very much focused on primary offering and not so much on liquidity, because if you have primary offering for very, idiosyncratic pieces of non-fungible investments, you're not going to have a lot of secondary trading, and that's a pity because the technology is optimized for secondary trading. It's a great, blockchains are great for trading. Indexes are a great innovation. And so if instead you start tokenizing things like commodities, for example, which are not so much focused on primary trading, but on secondary trading, which have huge markets, which have more appeal to alternative assets investors, I think you have a much better impedance match than you would with things like real estate, for example, which is not to say you shouldn't tokenize real estate. By all means, if you want to tokenize real estate, do it on Tezos. It's great. But I would say if we're going to see a lot of adoption and a lot of on-chain activity, it will come from these other assets. Another one that I can think about, for example, is market for computation. Today, they are ad hoc marketplaces for finding GPU compute. That's a thing that can be fairly easily tokenized. Gaming. So I believe gaming remains an important use case. And we haven't really seen gaming today on-chain. What we've seen is gamified crypto trading, essentially. But we haven't seen games that really tapped into successful game, I would say, that really tap into the mechanism which are afforded by chains. So you can have on-chain game logic. If you have a lot of throughput and if you have a lot of computability, you can start doing this. So it's not just you have your game and then they have a few NFTs. You can have the whole game logic running on a chain. You can have a seamless experience. You could have 10 millions of players making one transaction every 10 seconds. So again, if you're having like a very large MMORPG, you're not going to go on a blockchain that risks costing you $30 a transaction. That's not possible. So you really need to have this throughput before you even like see people attempting this type of use cases. One line here is like, what's the point of NFTs? And I think people get confused. And the main thing you'll hear, and I think it doesn't make sense, is, oh, I'm going to create a game, and you're going to have a sword in my game, and then other people are going to create games, and you're going to be able to use a sword that you got in my game into your game. That doesn't, I don't really believe that. The main reason is if you're creating a game you want to create and you want to own your own IP, you want to give your players their own sword in that game, why would you basically forego revenue by allowing people to use other items? I think it's possible if you have a massive franchise that's like massively successful and has like a massive amount of users, and then other people want to tag upon it and like get items from there or potentially currencies from there, that might work. But I think that's the exception rather than the rule. And the main benefit of NFTs is again outsourcing of regulatory compliance. So typically, games where you buy items do not let you cash them out, and there's two reasons for that. One is, why would they let you cash? Why would they pay you? They'd rather keep the money. They'd rather keep you engaged in a game and never cash out anything. So that's something that makes sense if you're a monopoly. It doesn't necessarily make sense in a competitive environment where you could have an edge over the competition by allowing your players to cash out. It could also be the case that by allowing players to cash out, you let them spend more money in the games. They may be willing to spend a lot more if they know that they can get some money back, as opposed to knowing that if they spend on a skin or whatever, they'll never be able to trade it. So I think the other reason is a problem of regulatory compliance, because getting money from people is something that's very easy, and sending money to people, all of a sudden they have to KYC everyone. All of a sudden they have to have all these worries about email and so on and so forth. If you do this thing with NFTs, it doesn't mean that those worries go away, but it means that those worries are now offloaded to other platforms. It means that you can have one platform that specializes in trading, and it's their specialty and their expertise that goes into doing this job. It's not the job of the game developer, so they can outsource, essentially, is the concern, which I think is quite important. And in theory, like big game platforms like Microsoft and such could provide this type of services, but they don't really want to be in this business. And also, you might not necessarily want to tie yourself forever to a big vendor. If you don't want to tie yourself together to a big vendor, that's a great way to do it, is NFT. So that really gets underplayed, and the story about the sword between two games get way overplayed. So reduces liabilities as well for developers, because you don't have to do this. As a developer, you do not want to be running an exchange. You want the people who know how to run an exchange to run an exchange, and you want the people who know how to run a game to run a game. So separation of concerns. Autonomous world, open collaborative game building, etc. Arts and culture, I think that remains one of the most beautiful use cases we have on Tezos. So for the art market, we can imagine large-scale, interactive, immersive NFT experience, letting audiences engage with dynamic NFTs in real time, being rendered on-chain in real time. Music, I'm an aficionado of music as a use case for NFTs, and the main reason is that I think music is a form of art that's consumed by the most people and collected by the most people. It dwarfs the size of the visual art market. And I love the visual art market, but I can also imagine hundreds of millions of people wanting to collect music. And no one's really cracked that yet. And I still think it's one of the most promising area of development in this industry. Ticketing, again, if you want to sell millions of tickets, especially over a short period of time, you need the burst capacity of having millions of transactions per second. So in a nutshell, what is unlocked by Tezos X? Cheap, fast, always on infrastructure. Think of it as almost a replacement for the cloud. It's very cheap, it's very fast, it's always on. You're not tied to a vendor. It's very convenient. It's just there. It will take care of your payments. It will take care of your identity, and you'll interact with a lot of other applications. Easy integration with existing code. If you have existing code running in, maybe you developed a whole .NET library, very popular in finance, for example, .NET. Well, Maybe you just move that to the blockchain. More on-chain logic, millions of users, and real-time experiences. So yeah, like I said, maybe a new kind of cloud. Serverless applications with built-in identity and built-in payments. That's, I think, the type of thing that you can build on a platform like Tezos X, which are not really possible with today's technology. All right, and now I don't know how I did on time, but I'll take questions if we have time for that. Thank you.
Hi, hello everyone. So you are putting a focus on minimizing costs, and I would like to know, is there a type of comparison using AWS services? If I use Amazon Web Services and I have 1 million users, I will know more or less how much it will cost me. Can you do this type of comparison using Tezos X? And like, is Tezos X going to be the Amazon Web Service for Web3? More or less.
Hopefully, I can't do this comparison now. I don't think it would be. I don't think it would be fair for me to do this comparison now. In my mind, the viability of what I described, it gets there if you are like 3 times more expensive than the cloud. Then you're within the realm of like when people might say, "Yeah, it just works." If you are 10 times, maybe not. So I would try to shoot around this. Of course, it's not exactly the same thing. If you have an EC2 instance to do lots of computation, it's not exactly the same thing as if you're running like a SaaS website, for example. So depending on the use case, it may be very competitive or not very competitive, depending on how compute heavy it is. But to go back to your question, I think about predictability, one of the issue of blockchain that sometimes fees spike and then it gets very expensive, whereas you have more predictability with something like AWS. I think transaction capacity is going to become very abundant, and a lot of the focus on, what do you do if blocks are full, is not really going to happen if you get to the point where you have so much capacity that you're almost never at capacity, that you always have some slack. What's interesting is that if you look at the pricing of blocks today, whether they're done by auctions or whether they are filled by burn mechanism, there's always this idea that the block is going to be full, and you're going to have a clearing price, which is like, what fee should you charge to ensure that you have exactly the right amount of transaction in your block. And if you do this in the future, fees are going to go to 0. Fundamentally, the idea is that blockchains are going to finance themselves via fees. It doesn't work if the fees are clearing. And I think what works is if by governance you install minimal fees. So I would imagine that the future looks like flat fees per transaction, where the protocol dictates that a cost or flat fee per gas, like a cost, the cost of gas is this much, and basically it acts as a floor so that you don't actually fall to 0. So that people pay it, and it should be low enough that people don't really care. It should be low enough that people are not going to bother to go to a competitor that might have a price that's slightly lower. And it should be high enough to try to raise revenue. It's kind of like the price of salt. How much does 1 kilogram of salt cost at a store? And I would assume most people don't really know. I mean, it's probably a couple euros or something like that. But it's not like if tomorrow the price of salt doubles, you're going to buy less salt. And it's not like if the price of salt halves, you're going to price less salt because it's such a small part of your budget. So you kind of want to be in that realm where it's low enough that people are kind of price insensitive about it, but high enough that you can raise revenue for the chain. And on very rare occasions do you start having congestion and having high prices. And for that, I think you can have, one of the beauty of proof of stake is that you can actually buy block space in the future by owning the token. You are able to create blocks, and by being able to create block, you're able to reserve for yourself the block space that you need.
I would go with one other question. So it would be more about adoption. We have seen the use cases, and I am thinking about the Open Network Ton and Coinbase, who has delivered Base. And basically, they build first users and adoption, and then they put the infrastructure. The way I see it is that Tezos is doing it the other way. First, we are laying down the infrastructure, and that maybe we hope for adoption. So what is... I mean, the technical roadmap seems great, but how do we onboard more developers, more users, more new blood, I would say, in the Tezos ecosystem. And yeah, so this is one of the questions. Yeah.
Sure. So it's not like we said, haha, we're so clever. Instead of like starting with users and building technology, we're going to start with technology. The reason that Telegram can do that and Coinbase can do that is that they started out as completely different businesses with very large user bases. And the reason they wanted to use the technology is because they said, hey, we have this distribution channel and we want to monetize it. Right? We're Telegram, we have all these users, let's build a blockchain and distribute it to all of our users. We don't have this user base. Likewise, Coinbase has this 60 million installs of their wallets, and they can actually push. And so I think it's always been a very, very strong value prop to have a vertical integration between an exchange and a blockchain, because the exchange can market the blockchain to its users. And we've seen it work very well with Binance and Binance Chain. With Coinbase and Base, and of course with FTX and Solana. FTX, was a decade-billion-dollar fraud, but they did make Solana. So it's unfortunate because we're not in this position. So we tried a few things. Some of the thinking behind sports sponsorship in 2021 was that they were very large audiences, and it was a way to onboard a lot of users, and then have them try different applications on the chain and so on and so forth. Conversion rates were, typically, as we know, are not very good. Here, we managed to get audiences interested in interacting, but it doesn't cross-pollinate all that well. I think we're still in an environment where the people who want to do things in crypto are very much in the crypto world, wanting to do crypto things. And so as a result, you need to have very, very strong alignment between the audiences that you bring and the type of application that you have on chain. So why focus on technology? Well, because we're good at it, and you want to lean on your strengths. And one of the strengths that we have is building excellent technology. Now, if you look at Tezos X, a huge emphasis on it is on developer experience. And there's a reason for that. We're not just building in abstract the best scaling technology. The reason we're building something like JavaScript is because there are millions and millions of JavaScript developers. So it's tied to a user and developer acquisition strategy, which is to go to a lot of developers who are familiar with one mainstream programming language, who don't necessarily want to learn another one, and to say, hey, you can apply your skills and learn something and use them directly on Tezos. So I would say the technical strategy is very much tied to user acquisition strategy.